problem, let's quickly talk about what simple interest is and what compound interest is, because it's important to know. Almost every other SAT, I think, has some problems relating to simple interest and compound interest. So relatively simple, and I think once you learn it once, it's an easy 10-20 points. So I would highly suggest memorizing a couple of these formulas that I throw around. So I'll start with this example. Simple interest. Let's say I have $1,000 and the interest rate is 6% on that. So if I go to the bank and I deposit it and they're telling me that my interest is 6%, simple interest, I have $1,000. So right now, let's call that times 0. I have $1,000. Fair enough? Now, 1 year from now, if I'm getting 6% interest, what I'm going to do is I'm going to have my $1,000 sitting in the bank account, right? And I'm going to get an extra 6% on that $1,000. So how do I do that? I just take 6%, which is 0.06, off 1,000. So this will tell me what my interest is. I had $1,000 sitting there, and then this is how much money I'll have. Whatever this calculation comes out is how much I'll have at the end of 1 year. Now we go to the second year. I'll have this much money now sitting in my bank account. 1,000 plus 1,000 times 0.06. So whatever this comes out to, I don't want to calculate it right now. And it doesn't matter for our purposes. So whatever this money is, I'll have that sitting in the account now. Plus, I'll get another 6% of my $1,000. So really, in simple interest, one thing you have to remember is whatever your initial deposit is, which in this case is $1,000, every single year you keep getting an extra 6% of that amount. So 6% of 1,000 is $6. So literally every single year, I'm gonna keep adding $6 to my bank account. So there's really a formula over here that we can derive, and the formula is you take the principal. The principal is that original amount, and then you add 1 plus RT. R stands for, and let's call that A, and A is the final amount. R is the interest rate. T is the time. So if it's 1 year or 2 years, 3 years, depending on how many years it is, we'll put that for T. And now look at this. I know this might get long, this might get annoying, but just have a little patience. Hear me out on this. Look at where this formula is being derived from. See that in step 2, I have 1,000 plus 1,000 times 0.06 plus 1,000 times 0.06. So between this, and this, what's common? That 1,000 is common, so I can pull that out. Now, what do I need to do to multiply? What do I need to multiply 1,000 by to get back to 1,000? The 1 plus 0.06 plus 0.06. Now, if I distribute that 1,000 all over here, it'll take me back to this example. So now, see that 1,000? That's my P right there. The 1 is coming from that 1 right there. And now this R is your interest rate, which is 0.06, and T represents the time. See how in this case it's 2 years, so that 0.06 is being multiplied by 2, which is just 0.06 times 0.06. Or sorry, not 0.06 times 0.06, that's 0.06 plus 0.06, which is what I have here. So the reason I wanted to show you this is so you truly understand where that formula is coming from. Now, make sure you memorize this formula. Make sure you memorize this formula. They're not going to give this to you. P stands for the original principal. P is the principal. Principal is just the original amount that you put in. 1 will always be there. The R is the, now let's take that R right here. The R will be the interest. And then let's take that T over here. T will be the time. And that's just in years. I know you might think to yourself, oh, I got this formula down, but I think if you don't look at this formula for the next 2 or 3 days, you might forget it. So write this down, revisit this formula in a couple days, especially before the test. Definitely revisit this formula. It's nice to know it. If it pops up on the test, it's an easy 10 points. So there's simple interest. Simple interest, again, just to kind of recap, you are taking the interest, which is 6%, happens to be in this case, from the original amount, and you're adding that every single year or from the original amount. Now let's really quickly talk about compound interest. So compound, if I'm comparing apples to apples, usually compound interest is the way to go. It's better, and I'll explain why. Again, we have $1,000 and my interest is 6%. So at year 0, I deposit $1,000. Now after 1 year, I'll get $1,000, which is my original balance, plus the 1,000 times 0.06, which will be the 6% interest on that principal of $1,000. Now here's where things change. Now in my second year, remember in simple interest, I was getting 6% of 1,000 every single year, no matter what happens. But in compound interest, I take 6% of this new amount. I don't take 6% of 1,000 anymore, I take 6% of this number, which will be 1,006. So let's get that down. 1,000 plus 1,000 times 0.06. Now this is just that amount right there. I'm going to take 6% of that and then add that to my original balance, which is 1,000. So here formula is going to be a little bit different. Let me write this formula down over here, and the formula here, let me see what's the best one that I can, or how I can make this a little bit easier for you to remember. You know what, I'll go with this particular formula over here. So I'm gonna write it down. It'll be P times 1 plus R, P times 1 plus R raised to the T equals A. So there's a couple of different formulas, but for the SAT purposes, let's stick with this one. This one is really a simple one, and this is the one that SAT uses. So P will stand for your principal like before, R is going to stand for your interest rate, and T is going to stand for your time. So in this formula, let's say if I was calculating compound interest for 2 years, my principal would be 1,000. 1 plus my interest rate is 0.06 raised to the second power. As simple as that. So 1,000 was my principal, that's my interest rate, and the T is my time. Alright, so this is an example of compound interest. Now, let's connect this all back to the particular problem that we did all this work for. Pedro and Joanna deposit money into their bank accounts. Pedro earns a 5% annual compound interest, so Pedro has a 5% interest. And his initial deposit is $2,000. Joanna, on the other hand, also earns 5%, and she's also got a $2,000 initial deposit. And really, J represents current balance, and P represents Pedro's current balance. Okay, current balance. J represents Joanna's current balance. Okay. Current balance, and Y is just the number of years. Which of the following equations can be used to find their current balance? So remember from our previous, I'm going to write these formulas down one more time. The simple interest is A equals P times 1 plus RT, while my compound interest formula is going to be A equals P times 1 plus R raised to the T power. So let's draw this line right here. This will be compound. And here we're going to have simple. Because Joanna is getting simple and Pedro is getting compound. So all at this point is just about plugging numbers in. So A equals P, which will be 2,000, times 1 plus 0.05 raised to the T. And Joanna is going to be A equals 2,000, yep, 2,000, same thing there. 1 plus 0.05 y. Right? That's really it. That's all I got. So, let's see. And then let's connect dots now. So A equals, I was just looking at the answer choices and see which one this fits. A equals 2,000 times 1.05 raised to the T power. And A is just my final amount, but the problem was telling me the current balance is P for Pedro and J for Joanna. So that's really not a big change, but just to match the answer choices. And let's see which one this matches up with. And it looks like it's going to be answer choice D. Answer choice D matches up with this. So that's it. And instead of that T, I messed up on a couple of these variables. Sorry. This should be Y because we're calling Y the number of years. And this over here, this should be Y too, just because the problem's calling that Y. Nothing crazy. And it makes the answer choice D.